I'm Dr. Peter Fisher here at St. Mark's Hospital in Salt Lake City. We're proud of the robotics program that we have built in this hospital, and I'm talking today about robotic surgery for prostate cancer, and specifically the procedure called robotic-assisted laparoscopic prostatectomy. A Foley catheter will be inserted into your bladder to drain urine. Your surgeon will make a small incision near your belly button and insert a plastic tube called a port. This port is airtight, and carbon dioxide gas will be pumped into the abdomen through this port. That gas inflates the inside of the belly, giving your surgeon more room to see the internal environment and move surgical tools. After your abdomen is inflated, a high-definition camera will be inserted so that the whole area can be easily visualized. Your surgeon will make an additional port incision or a number of incisions for robotic instruments, as well as for instruments to be used by a bedside assistant. The assistant at the bedside will insert and remove the robotic tools and other tools as needed through the procedure. Unlike standard laparoscopic instruments, tools for the robotic procedure can rotate 360 degrees and have greater degree of flexibility, much more like the human hand or the human wrist. The surgeon, while this is going on, is seated at a bedside console, sort of a virtual environment. Your surgeon will operate the robotic arms and the camera with joystick-like controls for his hands and foot pedals to control other instruments. A computer will translate the exact movements of your surgeon's fingers into precise movements of the surgical tools. At the same time, a high-definition vision system will provide a magnified three-dimensional stereoscopic view of the surrounding environment. As we get to prostate surgery, your surgeon will separate the tissues surrounding your bladder and further define your bladder, your prostate gland, the muscles of the pelvic floor, and the urethra. Part of the urethra runs right through the middle of the prostate gland. So using the Foley catheter as a guide, your surgeon will cut into your urethra between the bladder and the prostate. Each of the seminal vesicles and the vas deferens will be identified and separate them from the surrounding tissues. And each vas deferens will be cut as part of the process. To prevent injury to your rectum, your surgeon will separate it from the back of your prostate, and to preserve sexual function, your surgeon will carefully tease away nerves and blood vessels on each side of the prostate. Next, your surgeon will cut your urethra at the other end of your prostate and free the prostate so it can be removed. Lymph nodes near your prostate may also be removed to determine if there is any disease in the lymph nodes. And finally, the urethra can be reattached to the bladder by suturing very carefully using these robotic controls. At the end of your procedure, the tiny incisions will be closed with stitches, staples, and surgical glue or other closure devices. You'll have a catheter in your bladder to keep it draining and allow the anastomosis, or the connection between the bladder and the urethra, to heal. It's usually left in place for about 10 days. Historically, most urologists are trained in open prostate surgery, or making a larger incision to do surgery through. Nowadays, with robotic surgery, I would say 98% or more of the surgeries I do are done robotically. The reasons for robotic surgery include less blood loss for surgical patients, a quicker return to normal activity, and as a surgeon, the robot allows me greater precision to do nerve sparing, muscle sparing, to preserve erectile function and continence, and still do an excellent cancer operation.